Iodine is a halogen with the atomic number 53. It is the heaviest stable halogen, and the only stable halogen that is a solid at room temperature. It has many uses such as an antiseptic, disinfectant, and is a necessary nutrient. It also happens to be one of my favorite elements. To make it, we will need hydrogen peroxide, I am using 3%, sodium bisulfate, and potassium iodide. Sodium thiosulfate is shown here as we will need it to dispose of our iodine once we are done with it. Sadly, I have no good way to store it safely, and I currently have no uses for it, so I will not be keeping it. I'm not using perfect stoichiometry here because I do not care how pure the end product is, and all of the iodine will fall out of solution once the sodium iodide is reacted in its entirety. First, I took a small beaker and added some potassium iodide. I used a pipette to add water. I then set this solution aside and got a new beaker. To this, I added sodium bisulfate. I then added just enough water to dissolve all of it. This left me with a highly concentrated acidic solution. To the potassium iodide solution, I added around 15 milliliters of hydrogen peroxide. As you can see, the solution almost immediately became a yellow-orange color and started to fizz. I then added the sodium bisulfate solution. It became dark red and began to bubble even more. Solid iodine still didn't form, so I poured more hydrogen peroxide into the beaker. This caused solid iodine to form, as well as iodine vapors. If you look closely, you can see the purple gas above the beaker. This is why you need to do this in a well-ventilated area. My lab is, so this is not an issue. Iodine reacts with starch to create a vivid blue or purple complex. So to test any iodine vapors, I soaked a paper towel in starch solution and suspended it above the solution. As you can see, the towel became discolored, which indicates the presence of iodine. After letting the solution settle, all of the elemental iodine sank to the bottom of the beaker. I then set up for basic gravity filtration. I rinsed the beaker out with water to get small particles of iodine out. This is our solid iodine. As you can see, it is heavily discoloring the paper towel that I'm using to dry it. To clean everything up, I used a sodium thiosulfate solution, though you can use many other reducing agents in its place. It's important that you reduce any remaining iodine so you do not introduce toxic waste into the environment. Sadly, I did not have any demonstrations planned, however I'm planning on filming some iodine reactions in the future. You may have noticed that I got a new camera. It's a major improvement over my previous one. I will put the specs in the description if you are interested. I also got a new microphone, the Blue Yeti microphone, and this should improve the audio quality quite a bit.